So, we have done quite a bit of introduction to the course, automatic control. And till now, we have seen that we will represent the system as a block diagram. And we have seen various examples of the system. And we have seen the classification of control system. That is, one is open loop systems. Right? And other is the closed loop, or we call it feedback control systems. So one of the main features of open loop system is that you do not sense the control variable. It is more of a regulated kind of thing, that you just give it one command and it works on that command. If there is a disturbance to the system, there will be nothing to sense it or to correct it. For example, if you have a fan, you may say that we do set the regulator to some value. Right? You set it to some value, but let's say there is some disturbance to the system. So there will be nothing to sense that disturbance and nothing to take a corrective action based on it. There is no controller in it. Right? So one of the important features of closed loop system is that it has a sensor, and this does not have a sensor. So this is not present in the systems. There is nothing to sense the control. And since there is nothing to sense the control variable, there is no feedback from the system. Feedback is absent. For example, we saw it, simple washing machines, which are non-automatic washing machines, or a traffic signal kind of problem, right? In those, we do not sense the control variable, neither we send it to feedback. And since there is no feedback, so there is no comparison with the reference value. And then if there is no comparison with the reference value, there is no error signal. And if there is no error signal, so the controller does not act upon the error signal, but it just gives a command, a set command to the system. Right? The contrasting classification of control system is the closed loop or feedback system, whose main characteristic is that you have a sensor present in the system. For example, in single degree of freedom system, we saw that the sensor was displacement sensor, accelerometer, or a proximity sensor or strain gauge, and you sense the control variable, and then you compare it. You give it. You take this sensed value as a feedback. Right? This is taken as a feedback from the system. This is taken as a feedback from the system, and this feedback is then compared with the referenced value of the control signal. Based on the error, the controller takes corrective action, you can say. And this is the contrasting difference between open loop systems and closed loop feedback systems. The block diagram should be very much clear to us by now. Block diagram should be very much clear to us that you have a system, you have its output, this is your system. You have it output, its output, you take that as a feedback to sensor. The sensor value is compared with the reference. And the error signal is taken by the controller. The controller goes to actuator. This is the controller. This is the actuator. Right? This is the basic control block diagram for a closed loop, because this loop is getting closed. This loop is not present in the open loop system. With this, I think I'll end the introduction to the course. What we'll do now is making a block diagram easy for a system, right? It's very easy for a system. But what does mathematically this block diagram represent? For example, in a single degree of freedom system, I knew the equation of motion, right? mx double dot plus cx dot plus kx is equal to some force on the system, right? But how will you go from this representation to a block diagram? How will you go from here to here? So for that, we will be using what you have already learned in your mathematics, which is called as the Laplace transform. And this is what I would be doing in the next class. What does Laplace transform do? It transforms this ordinary differential equation to an algebraic equation. Right? So that is what we'll focus on in the next class.